Hi, welcome to ToddFun.com, where I do what I think's fun. And this week, it's a little bit of history. We're going to go back in time about 30 years. So if you're over 40, maybe 45, you might like this a lot more than the younger crowd, but even the younger crowd may like the fact that they're going to see a little bit of old technology and maybe just tweak a bit about the history of it and what us old guys cut our teeth on in the computer industry. I got on eBay, I got a Apple II Plus. Yeah, look at that. Isn't that something? I got it for a couple $100 from the original owner, who was selling just stuff in his closet, I guess. I don't know if it's fully working. On the auction, it said it was working, and he showed it working. The hard drive, or the floppy drives, did not work per the auction, but I haven't tried those, other than I know they're not functional. I first got this Apple II when I got it in shipping. It was pretty dirty, and so I figured, okay, it's dirty, it's full of packing pellets because the person just threw it in a big box full of packing pellets. And a lot of times, almost every time I get something off of eBay that's old, I take it apart, make sure there's no junk inside, make sure there isn't any parts rattling around inside before I even power it up. Why power it up and have it pop? So that's something I always do anyway, and that's a good piece of advice if you buy older equipment on eBay. Take it apart, make sure there's nothing inside. In fact, you'll see I did find something unusual inside one of these, inside of this machine, so that'll be coming up later. I, like anyone pretty much my age, we cut our teeth on this Apple. The Apple II Plus is what basically what we had in high school, or actually even junior high. I spent a couple of years coding one of these. I'm bugging the heck out of my math teacher, my physics teacher, because they had a couple of these in their rooms. I was constantly going in there, and eventually they did clear out a closet at our high school and put them in there so the students could go in there and use them and do some of their homework. And I was actually taking some classes later on which required us to use the computers. But even if I wasn't taking a class, I was in there all the time. I was quite fascinated with computers, and the Apple II Plus has a place in my heart because it was the first machine I ever really programmed on. A couple of years after I cut my teeth on these Apples, my parents and many of my relatives kind of got together and bought a home computer, a Commodore 64. From that day on, that was a machine that really settled in with for 4 years in high school and used every single day. So the Commodore 64 still is in higher standing, and I actually have, I think, 4 working Commodores. I actually set up a retro computer day for Mother's Day, and we all sat down and some of my relatives and we played old Commodore games all day. So that was our Mother's Day. So the Apple will be in the next one. So this is going to be a video on, I actually shot most of it, so it picks up where I basically got it in little pieces, and then I go through kind of a fly through of some of the components. I look at some of what I find interesting about the boards and some of the chips, a little bit of history on the Apple II Plus, just a little bit so people can understand a little bit of the history. There's a couple of unique things in there that I didn't even know myself until I found it inside and then started doing some research on the internet. So that's covered in there. And then after that bit, I'm going to shoot another part here where I'm going to power this up and see how it works. See if everything's actually working. See if I can get the floppy drives actually working properly or not. And see if I can remember how to run these machines. Might be a little bit interesting. I'll show a little bit of the basic programming language that these come with. It was a really good buy, a couple $100, but the shipping was pretty steep because, like I say, he shipped a couple of big boxes, but well worth it. It cleaned up really nice. I used some just standard kitchen cleaner with a little bit of bleach in it, and it degreased it really good. Actually, I should probably show what that cleaner was, because it cleans the grease off these cases really nice. Use a scrub brush, like a fingernail cleaner brush. And it's pretty gentle on the case. It doesn't even damage the coloring or anything. I did open up everything, including these drives. Didn't see anything really wrong with them. And always, when you get these old drives, these old floppies, before you use them, make sure you use a disk cleaning kit and run them up a few times in those disk cleaning kits to make sure they're clean inside. Last thing you want to do is put a perfectly good disk inside one of these dirty machines and have it destroy your disk. So I take them completely apart, I manually clean everything inside, And before I fire it up and put a disc in it for the first time, I'm going to put a disc cleaning kit in it, which uses a little bit of it's like an alcohol solution that comes with the kit. And something no one does anymore because you don't have to, because you don't use floppies of any kind, but something you had to do regular. You can still buy those disc cleaning kits. I have one and I use it all the time before I use my Commodores or before I use my Apples. So make sure you do that if you get into any of these old computers. Okay, and this is the cleaner. It's just a Clorox cleanup with bleach. Spray it on, use a fingernail cleaning brush, and it'll brush those plastics off real good. Make sure you take everything off though, so there's nothing there but plastic, because you're going to use this. You're going to use this spray, hot water, and scrubbing. So there can't be any electronics or components left. You have to really gut it down till it's just its case, which you'll see that's in the video coming here that I already did that. For the monitor, same thing. You got to take all the guts out to clean it and brush it, but including this CRT has to come out. Everything has to come out. Nothing left but plastic. Do not clean the screen with this cleaner. Just use a standard screen cleaner for that. And there's actually a fine mesh, kind of almost like a silk covering. You'll see it later in the video on this monitor. And don't clean that with anything either. So you want to just gently blow that clean. And I washed it down with some 100% isopropyl alcohol. Well, actually it's 99.95% isopropyl alcohol. That's what I cleaned the screen mesh with once I took it out, and the physical glass that's on the CRT. I cleaned it with this. And that's okay with this at all. It completely dries and evaporates and doesn't leave any residue. But I wouldn't use this on those components. This is just for the plastics, and it does take all that 30 years of grease off and leaves you with a nice, clean, shiny, bright plastic again. I know there's other solutions out there that make a cocktail that actually eats into the plastic a little bit and does even a better job, but I don't need anything that clean. Just get the grease all off, and these things don't fade to that ugly yellow so bad. It didn't seem to, so I don't need to do that type of a solution. But I, of course, have it all tore apart because I'm cleaning the plastics. Plastics was all yellow. You can see how yellow and icky looking the plastics is. Once I'm done cleaning it all up, it's really shiny and white again. Of course, I'm tearing apart all the boards and the keyboards and cleaning them all up, making sure everything's proper. Clean up my drives. These are the hard drive or the floppy drives. Took them apart and made sure they were clean inside. Got I guess they call it the main board, but it's a motherboard on an Apple. It's all been stripped down and cleaned up real good. I don't want to have any chance of this thing popping when I turn it on the first time. It came with this main chassis was full of the packing peanuts, and I mean full. They just had it in a box with packing pellets, and they all got ground up, and they got in all the cracks and crevices and inside the monitor and inside the drives. There was that white packing pellets everywhere. It was crazy. But that's probably for the good, as I had to tear it down then and make sure everything was clean. And I wanted to show the monitor guts here. I stripped the monitor guts out just to make sure everything was clean and everything was good inside. And what I found out, and this is what I want to show real quick before I move on, is there's this like a black screen. This is porous. It actually air will travel through this, and so will dirt and dust. And this is up against that screen, keep it black, I guess, and keep there from being glare. But underneath this was just gobs and gobs of dirt. I cleaned that thing about 6 times before the dirt stopped coming off that screen. It had dirt clung to it for 25 plus years. This actually looks like this computer was stamped in 1982 from some of the stuff I've seen. So yeah, if you have one of these old Apple III monitors, this is actually called an Apple III monitor, or any of the Apples that have these screens, and you can't seem to get them clean, take them apart, get that CRT out, clean that glass on that CRT, and I'll bet you anything this is going to be sharp and bright once again. So okay, that's about it. I'm going to finish cleaning up, get this monitor case nice and white, and then I'm going to put it together and fire it up. Well, everything's all cleaned up and ready to put back together, but I thought I'd do a flyby of everything and just talk about some of the stuff inside this Apple II Plus. As you can see, it's all cleaned up. This got a lot whiter These got wider than the monitor, but the monitor probably just had a little bit of an off tinge originally. It looks like it's almost the same color, but that's the best it could clean up. And yeah, this is 30 years old. Pretty much everything I found on it was 1982. So this is a 30-year-old machine. Let's just see if we can go through some of it. We got the motherboard here. Actually, Apple calls this a logic board, or a main logic board. Essentially, this is what we would call a motherboard nowadays. It has a speaker hooked up, and it's nicely laid out if you look at it. I mean, it's all, you know, like soldiers in a row, ready for battle here. It's copyrighted for the Apple II main logic board is 79, but many of the chips on here are right, and the date codes on these chips are pretty much 1982. The latest I found was, I think, the 38th week of 82. So somewhere in mid to late 82 this was assembled. Sort of just to take a look at it, this is a plug-in right here for the keyboard. The keyboard that would be here just has a cable that plugs in here. And then lots of 74 logic. Amazing how much 74 logic is in here. I guess you could look at some of them. You could, if it'll focus on them. We've got things like D flip-flops, quad multiplexers, ANDs, quad ANDs, 3 input ANDs, quad NORs, 8-bit multiplexers, XORs, 4-bit multiplexers. I mean, the list goes on and on. But lots of 74 logic in here. If you notice, there's a white line, a box right here. What this is the memory. Each one of these chips is 2K. So if you counted them all up, if you had every one of these sockets filled, you'd have 48K if all these were filled. Because there's 1, 2, 3, 4, 5, 6, 7, 8 in a row, and there's 3 of them. So yeah, you'd have 48K. And in fact, this particular board comes, they're all marked on the back with whether or not they're 16K, 32K, or 48K. And this is a 48K Apple II. If it had a chip right here, but it doesn't. Normally, I'm sure when I bought it and it first chipped, it had that last 2K chip there. But one of the things you can buy as an upgrade for the Apple II, even when it first came out, was to make it 64K. And what you did is you pulled out this last chip, and over here you have another board with, guess what, more memory on it. It has the rest of the memory, so that when that is plugged in there, right, snaps in right there, then this becomes a 64K Apple II. And this has to go in slot 1. This isn't just a memory expansion card. This is called a language card. And what it does is it sort of bit shifts all the rest of the memory into these first 2 rows of chips. Some more of those 2K chips. But it is a language board, and what it's designed for is you can actually load like Pascal and Fortran and other languages, and you can shift into them. You could actually say flip over and run the programming language that's on here. Now originally, when Apple II came out, Apple II had its base language on its internal ROMs, read-only memory. It had what was called Apple Basic, later named Integer Basic. It was designed by Steve Wozniak. Sorry. It had some pretty good problems in that the reason it was renamed Integer Basic is because it did only integers negative 32,768 to positive 32,767. You could simulate floating point operations, of course, but it was not easy to do in Integer Basic at all, and not at all. So what did Apple do? Apple went to, well, it's on the chips. If we could focus in on one, Microsoft. basically Apple went to Microsoft and had Microsoft write AppleSoft. And starting with the Apple II Plus, which is what this is, the Apple II Plus, we have AppleSoft, which is basically AppleSoft Basic. It's the basic language written by Microsoft, and it did do floating point integers very well, and it became standard for all future Apple IIs to have the Microsoft version of Basic as its language when it booted up on its ROMs. But nice enough with this language card, you could off the disk, off the master disk, you could load up the Integer Basic by Steve Wozniak and still run all the old Integer Basic programs that were still out there. You could do it without this card, but this card allowed you to have both the built-in Microsoft's Apple Soft Basic, and then it would automatically see that you have this language card and automatically throw Integer Basic on this when you start it up. And so you could just, with a keystroke, switch between Integer Basic and AppleSoft Basic. Or, like I said, you could actually go ahead and reload this thing with Fortran or Pascal or some other language and start coding in those languages too. So, very powerful to have the extra language card. Up here there's also numbers like 0, 1, 2, 3, 4, 5, 6, and 7. Those are the banks here. That's what these expansion cards go in, like a language card, a modem, a disk drive controller, and so forth. Not too different than current computers as far as expansion slots are concerned, except for they kind of pretty much have to put the language card in 0. You pretty much have to put your disk drive controller in 6, because that's where the programs look for them. They actually look for these by numbered banks, and so if they're in a different bank, you then have to tell it so. And of course here we have the main microprocessor. This is the 6502, and that is the famous 6502 done by MOS Technology. MOS stands for Metal Oxide Semiconductor. It's a company that was actually making chips for the calculator industry. And a guy by the name of Chuck Peddle, he wanted to design something cheaper than the Motorola 6800 processor at the time, that was selling for about $300, which is equivalent to about $1,400 today. And that's what everything had to use if it needed a processor. And he did work for Motorola, and him and some other people at Motorola basically got told to shut up and sit down and not do any such project like making a cheaper microprocessor. And so they left. They up and left, and they went to another company called MOS Technology, which was making these chips for things like basically calculators and stuff. And they basically settled into that company and started designing a new microprocessor. This particular one, they first came out with a 6501, and the 6501 was pin compatible with the 6800 by Motorola, which got them pretty much sued. So then they stepped back and said, okay, we can't do that. We can't completely compete like that without getting sued by Motorola. So they came up with the 6502, which simply shifted the pins around so that it wasn't pin compatible with the 6800 by Motorola. And yet it was cheaper, $25 instead of $300. And well, it was designed by the same people who made the 6800 or worked on the 6800 for Motorola, so you can imagine it was pretty powerful. And that would $25 then would be about equivalent to $140 nowadays. And so you can imagine this made things cheap, like being able to be the main processor inside of an Apple II. It was also in the Commodore 64, but I think in that one it was mostly flavored as a 6210. But it was also found in the Atari 2600 game console, the Atari 800 XL, and well, of course, the Apple II. So that's enough about the chip technology that's in there. Over here we have outputs for audio and mic. This is basically speaker and mic into a cassette recorder, because Apple IIs always came default being able to support writing all their data and reading their data from cassette recorders. Just standard, basically ear plug and mic plug. And you could use any standard recorder to store and retrieve your data. But that was slow. And so people, of course, wanted to get the floppy disk drives going, so they came out with the Disk 2 floppy drive controller, and it runs off of a cable, of all things. I don't like the way they cable things in the Apples. and it had to have a disk controller. So you put your disk controller in slot 6, and then you plug your external drives in off of those funky little cables that come in the back, and you were up and running with your disk drives. So you didn't have to use the built-in audio cassette recorder feature, but that's still there in case you want to use it. Then for the video out, you have just a RCA jack, which actually goes to this type of monitor, or any type of a monitor that takes an RCA jack. And then here there's another plug for doing televisions. If you got the basically just it's a module that was in a little tin can that plugged in right here, and then you'd have a cable that would go out right here, and that would go to a regular television, just your basically your rabbit ears on your television. But you had to buy that television RF box and plug it in, and it was an add-on as well. Of course, there's no point in having that if you have a monitor, because the images are better. This is a color computer, but my monitor is only green, and I like it that way because that's the way I originally used them. I don't want to see them in color. If I want color, I'll go with my Commodore 64. There's a socket here, which is for things like this, well, any type of game controller. And so they just plug in, like, once again, just a nasty cabling on the Apple II, between having to socket things into things and having ribbons for drives and ribbons for other peripheral. It was just silly. I don't like the cabling, but that's what they had. It is a color computer, and you got the color trim right there, but I don't have color, so I guess it's not really going to matter. This was made in Singapore. I think it said there. Yeah, it was made in Singapore. Whereas the keyboard is made in America, so go figure. And they call it the encoder board, and it's the keyboard. A real bugger with the Apple II is the reset key right here. Here's your enter key, and this is your reset key. Is that a joke or what? If you're typing along and you went up to hit your enter key and you fat fingered that reset key, you reset the memory. You reset the whole box. And that's why when you see the Apple IIe, this reset key is moved off to the side where it can't be hit so easy. And what a lot of people did aftermarket with these is they put rubber washers under them, like an actual rubber washer for a sink faucet or something. And what that does, it makes it really hard to push. One other board that came in my computer was this modem. It's a micro coupler. I don't know what baud it is. It is older. The chips are marked on this. I think you'll see one date code right there is 8012. That means it was done in 1980 and the 12th week. So, and everything on here is right at that date. So this was actually built a couple of years before my Apple II. So probably someone bought this later down the road, secondhand or something, for it to be older than the actual Apple. The power supplies were always inside of the main case beside the motherboard. I took the top off just to make sure it was clean inside. No date codes, but I'm going to, because it says it's a copyright 1980, I'm going to assume it's the same. It's basically just got your transformer in there and bridge rectifiers, and there you go. Not much, really easy to work on if something goes wrong though. Has a fuse down in there, so if you have an Apple and you have a problem with the boot up, you might have a bad fuse down there. This is like I said, the disc 2s that came out, so you didn't have to use the audio cassettes. Everything on here is also 82. Actually, I found one chip right here that's 84. If you see the date code on that, you can see it's 8416. So I don't know if this one, they got the drives a couple years later. But funny enough, most of the chips on here are 82. This one's the only one that's 84. So maybe it was repaired. And then the screen, like I said earlier, you gotta take this thing all apart to get this out. And this was really dirty. And like I said, that CRT was super dirty. So they're easy. They come out pretty easy. A few screws, and then just lift it carefully up and lay it down. Don't touch any of the wires on the back, unless you know how to degauss or decharge them. Then you're probably safe. So. Not much to look at here. On the front, this is just contrast and power. This is the big transformer with a date code of 8208. so that's pretty much the same time the Apple II was made. There's a fuse way inside the monitor. That would be really hard to get to, and it's soldered on. But there's a fuse there. If you have a problem with one of these monitors, you'd have to pull this board out and get to that fuse. And there's another fuse down here on the board down here. So if there's a possibility that you have two fuses in this monitor, it's called an Apple II or Apple III monitor. And on the back you have some controls for horizontal and vertical, and then brightness is over there. And then there's a few that we couldn't get to unless you took the back off, such as sub-hold, vertical line, horizontal sub-hold, and stuff like that. And actually I've got a new tool. This is a plastic adjuster. I have this older pointy one, but guess where this came from? When I opened this old guy up, this was inside. It was actually stuck down and jammed inside of here, and it was inside this monitor and jammed inside that adjustable resistor. And someone just put the monitor back together and left their tool in it. So hey, new tool for me. Oh, and something I wanted to say about the layout as well. It's large enough to where they can actually label the actual part numbers. You don't, rather than like nowadays, you'll just see IC1, IC2, IC3, and you need a diagram to tell you what to put there. And I think it's just so interesting that there's just so much space that you can actually put the part numbers. You could just start with a bin of parts and just start plugging in ICs exactly as silkscreened, and you could build this board just with that without even having a schematic diagram to reference what IC1 and IC2 were like we have to do nowadays. But I understand everything's smaller and tighter, and you need that room on the PCB, so you got to save that labeling. And then the other thing, if you take a look, is they're all socketed. Every one of these socket. You could pull these chips out and put another one in right now, but everything is socketed. I mean, that must cost. I mean, I understand the memory being socketed. They want sockets for people to expand their memory if they wanted to, but there's got to be a lot of expense to have all these socketed components, because that's, you know, added cost. Now all I can think of is maybe in 1980, maybe these parts, which I didn't work with parts in 1980, maybe they're really heat sensitive, and you can't be soldering them all on without damaging a few of them, and hence socketing solved that problem. Or, you know, maybe it is because they want it to be serviceable, and they wanted people to be able to, you know, just pop out one of these and stick in another one, and service is done. Well, in the case of memory, it would be expected, but all of these are socketed. So, yeah, I mean, if you just want some 74 logic, there you go. It's right there, ready to be used. And they even did the same with other cards. It's not like it was just this Apple logic board or motherboard. They did it with the language card. They did that same socketing with the drive controller. And this modem has a few that are soldered on. And there's 74 logic too, and it's soldered on. But a few of them are socketed. So, I don't know. I mean, even the drive over here, it's pretty much all socketed. So, yeah, I don't know. Maybe somebody out there who knows more about why they did that in 1880 can write onto the notes on the YouTube, or go to toddfun.com and on this and comment why you think that is, because I don't know. Okay, this just pops off. And inside, everything's hooked back up again. We have the language card, which I showed earlier, in slot 0. That's required because that's where it looks for that language card on boot up. And now we're going to put a drive on. And what you have is a drive controller with these. And the ribbon goes on with the ribbon facing out, away from the board. Goes into number 1, unless you have 2, then you got 1 and 2, so you'll have drive 1 and drive 2. I'm only going to hook up 1. And let's see, there's a little sort of like a grounding shielding clip. This is, if you notice, there's some shielding in there. Some like ribbon shielding that actually sandwiches between this ribbon. I suppose that's because this isn't a very good shielded ribbon, you know, so that was their idea for shielding. And this was sort of an afterthought as well for them. And this just essentially goes on the outside, feeds through, and this little clip, this little metal, is supposed to be the grounding part. It's supposed to basically just sandwich inside of the two layers, and then this is going to screw down and pinch that shielding cable. So it gives you some strain relief, as well as guarantees that shielding goes from this cable to this to the back. And we have the drive controller in slot 6. You want to use slot 6 on these Apple IIs because everything defaults to slot 6. We're looking for the floppy drives. You can tell it to use the other ones, and once you do set it to one of the other slots, then it will always go to that slot until you reboot, and it will default back to this slot. So use slot 6 so you don't have that hassle. I'm going to leave the back off the monitor so I can get to some of those pots and stuff in case things are a little fuzzy or out of sync or something.